Well,
Hey.
hello.
Hey, yo, yo.
I'm Monaco, and yes, I'm going to introduce myself every single time.
I'm his partner.
Mr. Milk.
Yeah.
We're in our third unit of study now. We're going to hit up chemical bonding. It's the
Yeah.
third number. It's not number 3.
Yeah.
It's the fourth that you're doing, but it's the third number.
Yeah. And if you think about it, we've learned about atoms. And then we learned how do we arrange those atoms. And now we're going to start putting atoms together.
That's it.
Like
Chemical
little
bonding.
puzzle pieces.
So we're going to hit up our themes, essential questions, targets, and assignments.
Yeah.
Let's do it.
What's up? What are we going to do?
So, why and how do elements combine to make chemical bonds? That's a big, big question.
That
Why
is
and
a
how?
major overarching theme energy-wise, for
Mhm.
sure.
Why and how?
And how do the way atoms combine lead to different properties with different combinations? Right. How's
Exactly.
that sound?
All the stuff that we see around us, its properties, its material, it depends how its atoms are connected.
True.
Okay. Why do molecules interact with each other? Why and how? So one molecule over here, one molecule over here. You feeling me? Yeah, bro. Or nah, bro. That's how it kind of works. They do interact with each other, and we're going to see how they do it.
That picture kind of shows us.
Yeah.
Little.
Secret code of the chemist.
Of course, you will be able to do your vocabulary for the chemical bonding unit.
That's your first learning target. You also have to be able to explain why atoms are going to react to form bonds, and following the octet rule, which is the little cornerstone there.
Cool. The relationships between energy when I make a bond or break a bond.
Yes.
So what's going on with energy?
Yep. Drawing models of bonding in ionic compounds. It's important. There's a pogo on it. It's not that difficult, but there's a certain method that will teach you. You call it ABCD. Works every time.
Every time.
If you know it.
Yep. And then we have to be able to name these molecules. The nice thing I like about this unit is it goes back and forth. If I have the name, I can draw the picture and tell you what it is. Or if I have the picture, I can tell you the name, and it can go back and forth and back.
Absolutely. Using charge cancellation rules to find chemical formulas for ionic compounds given a name. So like Mr. Milk said, if I give you a name of a chemical compound, what would its chemical formula be? How would you show the atoms bonding to each other in that particular example? It's important stuff.
Yep. Good stuff too. Now we can also have to draw covalent compounds.
Yep.
Using the octet rule, and we will be doing Lewis structures. Bohr is just about done, right? We're about done with Bohr model.
Bohr models are only useful for showing you the structure of an atom, and now that we don't know about the structure of the atom, we do want to know how atoms are combining. So we have to use a simpler model.
Right, and only the outsides are going to be
the outsides of the atoms interact.
We don't need the insides anymore. So
throw
the whole map is not really good.
We throw the kernel electrons out the door and only look at the valence and move on from there. Using the rules again to name covalent compounds given their formulas, and then backwards the other way, given a formula, what would be the name?
And then we can further classify these covalent bonds using the electronegativity values of the atoms involved.
Right.
Are they sharing equally, or are they sharing unequally? Is somebody being kind of a Grinch, if you will?
And what results from that? And that being said, intermolecular forces of attraction are a result of both polar and nonpolar bonds and polar and nonpolar molecules and how they interact. So the specific one we'll really be focusing on is hydrogen bonding, which is a type of intermolecular force, but there are 2 others that we'll just touch on briefly.
Yeah, here, and he just said something that's kind of a hang up all year, every year for kids, right?
Mm-hmm.
The difference between a polar bond and a polar molecule.
Yes.
So please keep that in mind as this whole unit goes on, because neither of us want you to get those 2 things confused. They're very different things, but the word polar is the same, and
They sound super
and that
similar.
idea is the same. But one's like on the micro level, and one's on a macro level.
Yeah,
so
for sure.
We got to keep that straight, I promise.
There's your assignments. Now, we did change a couple page numbers this unit, so the page numbers for the practice pages might be slightly off, but the concept still goes. If you're using a checklist to make sure you've done all your assignments, start on the left-hand side with homework, lecture 1, and move your butt on to the end.
Yeah.
Okay.
And let's not wait till the end of the unit to take our vocab quiz and stuff like that.
Yeah, I mean
if the CASEL quiz at the end, I understand it's more of a summation, but you got your vocab words written. Study them up. Do what you got to do, and let's take the quiz and get on with that.
Remember what Buddha says. The thing is, you think you have the time, but you don't. push the button and I turn off the beat.